Hey, how's everybody doing? So today I'm just going to kind of walk you guys through where we're at in this process, what's going on today. I'm going to give you guys an example of the project that I did or that I'm working on, and how I kind of work through these different steps in the process and how that kind of helps you to organize your thoughts and your design and your coding so that it's really as easy as possible, as easy as you can make it. But before that, I did want to spend just a second to kind of show you guys what I did this last kind of weekend when I was offline for a little while. So I went and skied up to my little cabin, spent the night up there, and then skied up this mountain. So this is from my parents' house. There's our little fire pit, and then if you look in here, this is actually this mountain right here is the mountain that we skied up to, is this point right there. And my cabin is right kind of down here, just over this ridge, just barely out of sight. So that's where we were going. We started off kind of hiking through the snow. You guys can totally skip this part if you're not interested in this, by the way. You can fast forward. But we started off hiking in the snow. We had to hiking on dirt. We had to hike on dirt for about a mile to get to the snow because it was so melted out. It's been pretty warm here. But eventually we hit snow. This is my friend and old roommate, Steve, who also teaches physics. And then eventually we got to the cabin. So it's Steve and my buddy Weston, me with some kind of booger on my nose, hanging out at the cabin, hung out on the deck, had a fun time, kind of spent the rest of the afternoon up there. Just hanging out, enjoying the sunshine, the clouds, made a little fire in the snow, which was hard to do, but we did it. And this is kind of the view from town, and got some beautiful views of the mountains up here, a bunch of little cabins up there, and then we actually climbed this mountain up here to this point, so that was where we were going to. And so the next day we set out, beautiful day, kind of nice clear blue skies. This was just a pretty view. This was the mountain we were going to, but it's a very pretty one next door that I've also skied to the top of this guy, kind of cool. But really pretty day, kind of set out skinning up in our skis up the mountain. Here I am, here's my buddy Weston, all in high spirits. Look at how happy we are. This was early in the hike when we were less miserable. But carrying on, kind of walked up, we went from the aspen forest and then now we're into spruce fir forests, so more like kind of similar to pine trees but not quite the same. And we saw a little grouse there. This little bird kind of came out and said hello to us, so that was kind of cool. And then kept going up. Here I am pausing to look introspectively up at the lodgepole pines and think about how tired I was at this point in time in the hike. But eventually we broke through past the trees up to timberline, just beautiful snowfields on top of the mountain there. And we were heading towards, the peak is actually over this. This is what we'd call a false summit, where it looks like the top, but it's not. But we were kind of headed up that way. First to this little ridge, so we kind of were skinning up there. That's a view kind of backwards down towards town. My cabin's way down here. So kind of cool. And then this is my buddy Steve, got kind of steep there. We were headed up towards this point, and then we're going to head over towards that ridge line. And we got up to this point, and this is what we saw. And I want to kind of talk about this for a second, because this is what we'd call a cornice, is the term. And it's just where the snow kind of blows over this ridge, and it all kind of piles up on this other side. And you can see all these cornices here. And this is probably 15 to 20 feet, probably 20 feet of snow out there. And it falls down on the other side to just these steep slopes. And you've got to be careful. You don't want to step on one of these or go out skiing on one of them, because they're not super stable. And if they break with that added weight on them, you die. So we kind of stayed well away from that and kind of kept hiking along that ridge. There I am, there's Steve, in good spirits because we were close to the top, or so we thought. Then we crest and we see we've got a little bit further to go. That's the actual top up there. This is my buddy Weston, way up ahead. Just this huge expanse of snow. It was really pretty up there. And eventually we got to the top and we're just treated with these views. This doesn't even capture them all. There's more mountains kind of over this little hump here, another mountain range. But you can see all these mountains, like 360-degree views all around you. You can see all these cornices, all these high peaks. And we actually kind of ski down this way, down to the right here. And you can see these are the mountains that are above Aspen. Really pretty stuff. We skied down this little gully here. That's Red Table Mountain, also very beautiful. That's that mountain that I took that picture of earlier that I've also skied. Very pretty. So yeah, just pretty stunning. Here I am looking kind of introspectively out at the mountains, just enjoying the beauty, and the snow. Is a really fun trip. And there we all are, just kind of happy as can be. Bunch of crazy skiing people. So that was my trip. Figured I'd share with you guys because it was kind of interesting. And then carrying on where we were with this project. So hopefully you guys have picked out your projects. The one that I was looking at doing is this one, the sun tracker. Now I imagined it's really just some kind of a light sensor that can track kind of the solar angle But I kind of envision it as like being attached to a solar panel, so you could have a solar panel that kind of, because they're most efficient when they're facing directly towards the sunlight. So if you could have one of those that could automatically adjust to where it's always facing the sunlight, then that would be good. So a few requirements: it has to follow the sun as it moves across the sky, and it needs to stop seeking the sun when the light level drops to a point where the sensors can no longer function. And they gave me a hint, although I've already looked at this one and thought about it a good bit, but you need 2 sensor values to determine which way to turn, right? So it can't just be one sensor to say, hey, you know, is it brighter over here or brighter over here? You need 2, right? One to tell you kind of where the sun is so you can actually turn. So here's kind of the design idea that I came up with. Okay, looks something like this. It's like you got a solar panel, and it's got these 2 flaps on the side that are angled out, kind of like this. Here's kind of a top view of it, right? And then the panel can be turned by a single servo motor that's attached to a base. It's at an angle that's kind of facing the sun already. And then essentially, these 2 light sensors are picking up different light levels, right? They're continually sensing the ambient light, and if it's brighter on one than on the other, then it'll know which way to turn. And the way that works is if it's right on, if the sun is directly in front of it, right, then the angle to both of these, it's just slightly off angle, and so they're getting about the same value. Whereas if the sun's kind of more to the left, then this one at this angle is going to be getting a high value because it's getting all this direct sun, and this other one is going to be getting a lower value because the sun's kind of coming in at an angle. You can imagine that these light sensors would be kind of recessed a little bit, so they might be shaded if they're at an angle. And then they'll be getting sunlight more so if it's directly facing the sun. And so in that way it can kind of know which way to turn. From there I kind of came up with a little bit of a flow chart, right? So the idea is that we'd kind of go ahead and set the servo to 90, which would be that middle position, and we'll say that the thing would be designed so that 90 is at high noon, right? And so then if it needs to go to 0, then it can turn one way. If it goes to 180, it can turn the other way, right? So it can track the sun all the way across the sky. And you're going to go ahead and sense the light levels of those 2 sensors. First question, is it light enough outside to operate? So is either one of the sensors getting a value that's greater than 500, for example, or some minimum value for them to actually turn on? If no, then you're just going to kind of wait. You're going to hang tight and essentially be in wait mode and continue kind of sensing, waiting for it to turn on. And if it is greater than, if one of them is picking up light, then you're going to essentially ask a series of questions, right? Is sensor 1 equal to sensor 2 plus or minus 10, like within a range of play? If it is, then you're going to stay in that position at that 90, and you're going to wait. If not, you're going to say, hey, is sensor 1 greater than sensor 2 plus or minus 10? If so, you're going to move the servo to the left, right? So you're going to kind of translate it to the left, move towards the sun, continue sensing and going through this loop. And if no, you're going to ask one last question, is sensor 1 less than sensor 2? So we have our 3 options kind of covered that we can have. Sensor 1 can either be equal to sensor 2, greater than sensor 2, or less than sensor 2, plus or minus 10. And so then you're going to, if it's any one of these cases, then you're going to know how to move the servo, and you're going to kind of continue going through these loops, right? So that's the bare bones of kind of my code. Set up a few I know what sensors I'm going to need. I'm going to need 2 light sensors, a servo, and the variables, right? I'll need a variable to keep track of what is that right, or the one light sensor 1, what is that value, and what is the value for light sensor 2? So what am I reading on those 2 sensors? And then I'm also going to need a variable to set the servo position that I can change, right, so that I can set it depending on which way I need it to turn. Okay, so that's what I went ahead and I did that, and then from there I went ahead and consulted the ultimate Arduino guide, right, and I knew that I needed a light sensor, right, so I went to that bookmark page and I saw how to set it up, and I also saw the same with the servo motor, right, went to that and saw how to set it up. From there I created kind of my Tinkercad project that has my 2 light sensors and my servo motor all kind of hooked up, ready to go. All right, so I've got everything set up, and then now I'm ready to start coding things and start setting things up. Well, fortunately for you guys, I went ahead and did a little bit of that work for you. So I have the basic code to control and set up a servo motor here. I also have the same for the light sensors, right? Now looking at the 2 of these, I will tell you that the servo is a little bit more complex to set up. So what I could do is I could just type, I could kind of make note of all these different things that are in here. I could type them in kind of myself, or I can just take one of these, either one of these, and I can throw in the entire thing. I can just copy and paste, and then, oops, whoa, that's not cool, man. Yikes. Let's try that again. And then I can just copy and paste. Okay, Control C, copy and paste that into here. To get it to work, right? To get that right off the bat. Okay, so the first thing I need to do is I need to reference the servo library. I'm going to go ahead and delete some of these comments because I don't need them. And then I have the angle, variable to hold the angle for the servo motor. So I'm going to call this servo position, right? So I've got that variable there. I need to name my servo, so I'm going to call it servo1, right? And then I start my setup, right? So I need to attach servo1, and I need to attach it to the pin that it's on. Now here I actually have it on pin 10, so I'm going to attach it to pin 10, right? And so now that servo is pin 10. So now anytime that I'm referencing that servo, I know it's on pin 10. And then I have this loop, right? So I have my position that I can set, and then I can servo right at position. Now I'm going to go ahead and change those to what I named that variable, which was servo position. And then that's that. Now, one thing I know looking at my flowchart is that right after start, kind of within this setup, before any loop start, I'm going to go ahead and set that servo to 90. So one of the things I'll do in here is I'm going to go ahead and say, hey, the servo position 90. I'm going to cut that, Control X, and then Control V, and I'm just going to do that right here in the setup, right? Because I want it to do that once, and then it's going to run through those loops later. And those loops, if I look at these are essentially going to be a bunch of if-else statements, right? If sensor 1 or sensor 2 is greater than 500, then do this. Else, wait a minute and go back and then restart, right? So got this set up. So the other thing I need to know is I need to know the servo right is the command to actually write the servo at the servo position, right? So let's say servo position right off the bat is 90, and then we're going to go ahead and do servo 1 dot write, and we're going to write it at servo position, right? So that's in that setup. And within this loop I can do kind of whatever I need to do, right? But knowing that the servo right is the command servo right to write that servo at that position, right? And then so I'll go ahead and clear everything in that loop. I don't actually need that. So that's kind of setting up my servo so that I can control that servo. Then we'll want to go in here and look at my light sensors. So I'll go to that bookmark. And let's see, so I know I set up I name my light sensor pin, I make a variable for the light level, and then I start the serial monitor, so I'm actually tracking what the light levels are in there. That's kind of an optional thing. And then the light level is equal to whatever you're reading on the light pin, right? And then you print that, and then that's about it. So I only really need a few things, right? I need my variables, right? And then my kind of pin names, and then my variables. So I'm going to go ahead and copy those into there, and go ahead and put those up here. All right, so let's see. So I have a light pin, and let's see, what should I name them? I'll call it right light sensor, right light sensor, and that's going to be, let's say that's going to be the one on A0. And I'm also going to create a left light sensor, and that's going to be at A1, right? So now essentially anytime that I'm referring to right light sensor or left light sensor, I'm referring to pin A0 or A1, right? So those are the pins that those are on. And I'm going to create some other some other variables, integer variables. So I'll make, let's see, instead of light level, I'll do right light level, and I'm just going to make them 0 to start. Don't actually need to give them a number to start at all, but I will. So that's that. Okay, so now I have my pins that I'm referencing to, and that's just useful in case I ever like move these pins or any other thing like that. It's just kind of useful to kind of name your pins based on your variable that you have, based on what's kind of on them. And so then that way you don't have to remember, you don't have to worry about it, you just remember the name, and you don't have to remember the actual pin number that it's hooked up to. And then these are my variables that I mentioned here, right? I need a variable for the servo position and for the right light sensor and the left light sensor, right? So I already have those named. So then in the setup, if we look at our kind of flowchart, we set the servo to 90, and then we start asking these questions, right? We sense those light levels. So there we're starting to loop. So if I look at reading the light levels, right? if I want to read the light level, this is the command for it, right? The analog read, because it's on the analog pin. So the variable, right, light level is going to be equal to the analog read on that light pin, on pin A0, right? So within this loop, one of the first things I'm going to do is I'm going to do, what are my variables? Right light level. It's a little bit too far. You want to kind of keep track of things with indents, so I'll do a couple spaces there. Right light, okay, we'll do left light level first. The left light level is going to be equal to analog read, and that's going to be on my left sensor pin, which is the left light sensor. Make sure I spelled everything right there. So now that's going to say is that whatever the left light level is, right, whatever the value that's reading is going to be set to that variable now. So I'm going to read whatever's happening to that pin, and I'm going to set it to this variable here. And I can do the same for the right. Just copy this, and I'll just change all these to my rights. Oh, that's silly. Perfect. Right. So now I have these two variables that I'm reading, and let's say that I do want to know what those are. I can always do my little turn on my serial monitor, right? And then I can go ahead and let's double check the code on that. Serial prints, right, those light levels. Right, so I'm going to, let's see, serial prints, let's do right light level. And then that's going to be printing the value that I'm getting at the right light level. Right, so here I'm referencing the variable here. Since it's in the quotes, it's just going to actually print that, right? And let's say I want to do it on the left one as well. Right, I can go ahead and copy this. And here I don't want the LN there because I don't want it to be on a new line. So it's going to say right light level equals that, and then here, so let's do left light level. And we're going to do left light level. And then here I'm going to go ahead and add a tab in there, so it adds a space. And then we'll just add in a little, let's see, a little delay for just like a second. A millisecond for it to kind of catch up and read everything. Okay, so right now all that I'm doing, all that I've coded for is I've set up kind of my different variables where different things are. I've set my servo position within the setup to 90, and then I'm starting to read these light sensors, right? So I'm doing these analog reads of these light sensors, and I'm actually printing it out. So now if I actually go ahead and we'll see if this works, if I start the simulation. Oh no! Analog read. Oh. Oh, did I forget that capital R? That's what I did. Analog read, gotta remember that capital R. That's very silly. There you go. Hopefully I should fix it. Whew. All right. So there we go. Let's go ahead and running through. You can see how kind of slow it is actually running right now. But it's going to go ahead and set that servo to its neutral, to its 90 position, that starting position. And then it should be reading these light levels. So you can see right now it's at 54, right? And I can kind of vary these and we'll see what happens. That's the... Ooh, I might have to switch those because that's the left one, but it's on the right. That's a little counterintuitive. Right? And we can see the max, right? It's at 974 is the maximum that I'm getting. And then that can go all the way down to... Oh, so it drops kind of very quickly. So it rises very quickly in this range, and then it drops very quickly. All right, so that kind of gives me a range to play with. But I'm going to go ahead and stop this, and I just realized I want to switch these. Now the nice thing with naming these is now I can say, hey, I want the right one to be the one that's connected to pin A1, right? And I want this one to be connected to A0, and I don't have to change anything else. Right, now it's good. Now they're actually all right. But so you can see when you run the serial monitor, things go a bit slower. So let's say I wanted to kind of mess around with this and not run the serial monitor. Okay, one thing that I can do is I can go ahead and make this a comment, and make all these things where I have the serial monitor. I can make those a comment. And then when I start it, hopefully it should be running a little bit faster. All right, so now you can see it's running in more like normal time, and I can still adjust those. Okay, so that's useful. If I want to see the serial monitor, if I want to see those numbers that I'm getting, I can let that code run. If I don't, I can put those comment slashes in front of it, and then it's a little bit better. Okay, so from here, I've essentially, let's see what I've done so far. So I've done the start, I've set the servo to 90, and I've created in my loop, I've started to sense the light levels. Okay, now then I might start my first if else. So is it light enough out to operate, right? Is sensor 1 or sensor 2 greater than, let's say, 500? So let's just use that as a range. And so we've read our sensors. We're going to delay, and then let's go ahead and say, so if, and I'm going to put in my condition here. So my condition is if, let's see, it would be the right light level. I'm going to do my OR, which is 2 vertical bars. Or let me double check that. Fairly certain it's 2 vertical bars. Let's see here. So logical OR right there, the 2 vertical bars. So if light level we'll say is greater than or equal to 500, or left light level is greater than or equal to 500. So if either one of those is true, right, then I'm going to do whatever's in between these brackets here, right? So let's see, what do I want to happen in between those brackets? If that happens, if that's true, then I want to run through all this. Else, I want to wait a minute and then go back to the start. So let's go ahead and do that. Let's go ahead and, so I've got that spot for that if, and then I'm going to go ahead and do the else. So if that's not true, all right, what I'm going to do is I'm going to, need to open up that bracket there. Delay, and how long did I say? 1 minute. So there's 60 seconds in a minute, so 1,000 times 60, so 60,000 milliseconds. Woo, that's a long time. And I don't want to wait a minute, so I'm just going to say like delay, say just 5 seconds for now, 5,000 milliseconds, just as kind of a placeholder. And then that's going to close that, right? So it's going to read those levels. And it's going to ask that question. If that's true, then it's going to do one thing. Otherwise, it's going to delay, and then it's going to start back up at this loop, right? So it's going to continually go through this loop. Now in this if, right, what I might want to look at then is I've got this series of questions. Is sensor 1 equal to sensor 2 plus or minus 10, right? And then I can add that into here, right? So I might do if that, then I'm going to add in another if, right? And that's a nested. And so here I might have this condition. And then close that one, right? Else if, and then my other condition. Right? I'm going to say stuff just as a placeholder. Right, and then finally I'm going to do one more else if, and that should cover all of the scenarios. Else if condition, then there you go. Right, so if, here we are, if this, right, you're going to do that. Else, if this, you're going to do that. Else, if this, you're going to do that, right? And so then I can code it to set those servos and all those kind of things. So I'm going to wrap off and tell you guys that for now. I'll kind of wrap up this code and show you guys kind of my final product next time and how it ends up working. But this is kind of the essential, the basics of how you kind of set things up and make it so that you can actually start to use these different sensors and actuators and start to code to kind of fulfill your project's dreams. So I hope this was useful. I hope that you guys are hanging in there and doing great, and I will see you guys next time.